I want to talk mostly about cognitive psychology, which is the modern style study of how people perceive things and think about things, and a little bit of cognitive anthropology, which is about how you understand how cultures work. The word cognitive basically means thought and related things, including perception. And over the last 50 years, we've actually made a whole lot of progress in understanding how the human mind works. The modern cognitive psychology and brain sciences it's an interdisciplinary adventure between artificial intelligence researchers who program computers to do things like thinking and planning, and psychologists who study actual humans thinking and planning, anthropologists who study how social structures work given the way people think and plan and things like that, and linguists who sort of specialize in language, how people speak and understand each other. And one of the things that's interesting about this is we now have a pretty clear picture, and most people don't realize this, of how people, in general terms, of how people think and why they have feelings and feel the ways they do when they think the kinds of things they do, and of the relationship between thought and emotion. And it's very, very relevant to issues of religion in a couple of ways. One is that religious theories, religious belief systems in general actually embody a lot of theories about things in the world, like what's moral, what moral reasoning is like or is supposed to be like, what's right and true, like do the gods tell you things, do your ancestors give you advice, is somebody going to punish you in the afterlife, and things like that. So actually knowing how minds work and how cultures work in general shows that the religious belief systems about, the religious belief system within a culture generally embodies certain theories about how minds work and how morality works and how that culture works, and in general they're not true. And if you actually do understand how minds work and how cultures work, you can tell that. Another thing that's interesting to atheists or people interested in atheism is that if this stuff is not true, if religious belief systems by and large are based on various kinds of errors, then why do people systematically make those kinds of errors? And there's a lot of different theories about that kind of thing. And the picture is getting clearer and clearer in cognitive psychology and cognitive anthropology of what really are the causes, what's the actual nature of religion and the causes of religion. So I want to talk about a couple of books. The first one is How the Mind Works by Steven Pinker. So this is a really well-written book. I'm going to talk about a fair number of cognitive science ideas, and this is the book I would recommend for anybody who's not very well versed in this. It's a really excellently written book. Pinker is a brilliant writer, and he's a very smart guy, and I agree with most of the stuff in the book, especially the first two-thirds. Everybody ought to read the first two-thirds of How the Mind Works. And the last third, there's more speculative things that a lot of cognitive psychologists would disagree with his particular take on certain things. But I think the first two-thirds is mostly uncontroversial among people who are experts on this kind of thing. And it's very well written. So it's a fairly trustworthy book. Another book I want to talk about, if we have enough time, is Religion Explained by Pascal Boyer. And this is specifically about the cognitive psychology and cognitive anthropology of religion. Boyer is an anthropologist who goes off to Africa and works with various people and talks to them about how they think, and he talks to other anthropologists who talk to various other people. And what he's trying to do is come up with a fairly detailed picture of what kinds of religion are essentially possible or impossible. What kinds of things are religious beliefs, and what kinds of things can become religious beliefs, can be integrated into a religion. Why do cultures incorporate certain things and exclude others? So if you're specifically interested in religion and you can absorb material pretty quickly, then you might want to go and read Religion Explained. If you want to take it a little slower and you want to learn something about cognitive psychology, which is very fascinating stuff in itself, then I'd recommend How the Mind Works by Pinker.
As for what kind of things can be included in a religion, though, isn't that practically anything in a society? I mean, essentially, they have religious strictures on how to live your sex life, how to comb your hair, how to, what you should eat.
In a certain sense. I mean, there's this amazing zoo of things that can be in a religion.
Yeah.
But there's an even bigger, not so amazing zoo of things that can't.
Okay.
So, for example, religions very seldom incorporate things that are fairly obvious. Because, if your religion says, there's such a thing as gravity, and that's important to our religion.
Okay.
Well,
good point.
there's no point. And religions also tend to incorporate things that bear on certain kinds of issues people find important.
Okay.
So, for example, there is no religion, and it's unlikely that there ever would be one, that says God is omniscient on every other Tuesday. And anyway,
he has his good days, he has his bad days.
And he doesn't care very much. He basically, religions incorporate things that serve certain functions in a belief system that people are prone to explaining things that way. And so as an anthropologist, he's looking at lots of cultures, certain cultures he's lived in, and other cultures he's gone and lived in and studied. And lots of other cultures other people have studied. And he has sort of these lists of, you could find this kind of thing in a religion, but you'd never find this kind of thing in a religion. And some of it's pretty amusing to read. Okay. One of the surprising things to many people about psychology is it's really gotten a lot better in the last 50 years. If you're looking at experimental psychology, there was a big problem starting with Freud roughly, that Freud wasn't nearly as scientific as he liked to think he was, and he built a cult of personality around himself. And a lot of people just thought he was such a genius that he had it all figured out, when really a lot of it he was just sort of making up. And basically, since roughly World War II, enough people have been disgusted with, on the one hand, Freudianism, and on the other hand, behaviorism, which was a reaction against Freud that went too far the other way, that they've started doing more careful analysis of the concepts of psychology, more careful experiments that actually reveal deep things about how the mind works. And one of the really important things was the rise of the computer, and the idea of the computer, even before computers were actually common and most people had them. And the emerging view that I ascribe to, I'm a computer scientist myself, is that the mind is basically pretty much like a computer program, and the brain is a computer, literally a computer, not just metaphorically, but not a whole lot like the computer on your desk if you have one. So the brain is a computer and the mind is a program running in that computer. And the task of psychology, as cognitive scientists see it, is to explain what that hardware is like, why it can do the things it can do, how it does the things it can do, and what program it's running. Why do we think certain thoughts and not others? And in general, cognitive psychology has been very successful using a lot of different tools. In particular, started out actually well before 50 years ago. This started when people found out that people with certain kinds of brain injuries think differently from the rest of us. And when you look at abnormal brains and the ways abnormal brains malfunction, somebody who's had a part of their brain damaged by disease or an accident or whatever, you find out that certain regions of the brain do certain parts of thought. They think about certain kinds of things. They process visual information in certain ways. They process sound in certain ways. They serve a certain role in remembering things and not other kinds of things. And so if you go and selectively damage different parts of the brain, and they can do this in non-human animals and experiments, you find out that the brain physically is mostly a collection of little computers that serve certain computational tasks. It's one big computer made out of billions of tiny ones grouped into modules that do some task, like, for example, the retina of the eye is actually part of your brain. The sensors and nerves in the eye itself are actually part of your brain that sticks out. And when you look at the world and you see things, you take that for granted. You just think, well, I got some eyes that plugged into my brain so I can see. But there's actually vast, vast amounts of computation and many different kinds of computation going on in the neurons that make, starting with the retina, and going back through several different layers in your head. So, for example, the retinal cells, they communicate with their neighbors. So a retinal cell that's looking at part of what you're looking at communicates with the retinal cells adjacent to it to enhance contrast. They'll sharpen up edges. So the image processing computations start in the eye and then are piped back to the back of your head. And in the back of your head, you have another stage of visual processing where the image that you're looking at, with the edges enhanced and a few things like that, actually, when you turn your eyes, it slides around. This pattern of activation slides around the back of your brain. And then there are several different layers of neurons that process that image and detect features in it. You have line detectors and texture detectors and various kinds of color processors and things like that that are performing this task that seems really easy, and most people have always taken it for granted. Vision is just something humans can do. Why think about it? But the more you study this kind of thing, the more you realize it's computation. It's vast amounts of computation. So that, for example, just to know where this cup is and to know that it's a cup requires many, many stages of processing, all of which involve a lot of guesswork and a lot of computation.
I think I had actually seen one time on TV, I can't remember exactly what the condition was, but I think this guy was blind pretty much from birth, or a very young age. And then when he was like 40, or in his 30s or something, he finally had some kind of surgery where he got his vision back.
Right.
And essentially, you almost feel like, well, once they, flick that switch, he can see again and life is fine. But he hadn't learned how to see.
Right.
And so there would be something in front of him, and he didn't know what it was. He couldn't tell anything about it. He learned that maybe it was round and orange, but it doesn't mean anything. But as soon as he touched it, because that's the sense I was used to, he knew immediately that's a basketball.
Right.
If he would be at a basketball game, he may get confused between the ball and a car that's in the background that's the same color, because you haven't learned to differentiate. They're just the same colors.
Right. And so, given that our brains, the parts that we don't have conscious awareness of, just plop these very heavily computed things into our conscious awareness, it conceals the fact that the task of vision is incredibly, incredibly difficult, and it takes a massive computer that's got lots of different parts doing different things to do it. So, for example, when your brain first gets just a bunch of bits, essentially, from your retina, a raw image, it doesn't know anything that's in it. It has to detect regions of color and things like that, and it can be confused by all kinds of things. Like if there's a shadow falling across something, like me, say, then different little modules in your brain that do different parts of vision may have different theories about what you're seeing. That it may think, okay, this is one object that changes color here, and then changes back to this other color here. Or it may think, oh, there's three objects. There's this color one, and then there's this darker object, and this other object, and they're stacked up. And then there may be another one that says, oh no, that's just shading, and that's really all one object, and that one has to win for you to perceive my face correctly. So there's a lot of guesswork and a lot of voting and a lot of overruling of the theories that are made by little parts of your brain. That your brain, all the time, just looking at things, is coming up with thousands of theories, a lot of which are false, that are being overruled by other parts of your brain that integrate the information and filter it and interpret it some more. Let me see. I'm actually getting a little ahead of myself here.
Yeah, I have seen that. But again, having to learn, again, it almost seems like parts of your brain would just plain work.
Right.
And it would be kind of built in.
And there's this one of the reasons why the brain is very difficult to study, and why, even though we've sort of charted out the rough geography of the brain, the rough organization of the cognitive modules that actually do the work, there's lots of theories and lots of controversy about lots of the details. So, for example, there's a part of my brain, and a part of yours, that basically only kicks in when looking at faces.
Yes.
And what it does is it recognizes really subtle cues, really minor differences in curvatures and things that you cannot articulate consciously. You don't know what your brain is doing. You don't know how you recognize a face, which is why it's so hard to describe somebody's face and have somebody else go, oh yeah, them, right? Oh, you mean the guy with the beard? We're sort of limited to, beard, big nose? I don't know. But we can recognize millions of faces and we have essentially no idea how we do it. Well, this is one of the parts of the theory that's controversial, is how much of that is built in. How much of that is genetically programmed to develop under the right circumstances and will just do that. And like recently there was a result about the part of the brain that recognizes faces that suggests that that part doesn't have to just recognize faces. That what it really is not just a face detector, but that's probably why it evolved. That's the most crucial thing that we do that kind of discrimination for. But it's able to discriminate lots of subtleties and shapes and things if you have a lot of knowledge about those things, a lot of experience with those things, a lot of it to work with. Okay. So it turns out that car body geeks who spend their time looking through magazines and geeking out on the design of car bodies, and have done this for years and years, like car body designers. Turns out that same region of the brain can tell them the difference between a 64 Corvette and a 65 Corvette. So that's the kind of thing that there's a lot of little mysteries about. Is this part of the brain really just for this function, or does it do this kind of computation? But there's a lot of things that we know. It does that kind of computation. So it does the kind of computation you have to do when distinguishing between my face and yours, even if I shave and you shave, and I shave my head and whatever. How do we distinguish between faces? It's essentially the same kind of computational problem of subtle shading, inferring subtle differences in curvatures and relationships between different curves that you do when recognizing the difference between two kinds of Corvette. So those things are controversial, and scientists studying the stuff love to fight about it. But they all basically agree that most of these things are there for some clear evolutionary reason. So why do we have the ability to make such incredibly subtle visual distinctions? So we can not only recognize millions of different faces and tell them apart. Mm-hmm. You can say, nope, that's not the same person as that. We can recognize them under all kinds of different lighting conditions and which way they're facing, which makes it a much harder computational problem. We also have another region of the brain that for faces we do recognize does lots of extraction of stuff about facial expressions, or even for faces we don't, that pretty quickly you get a handle and categorize the face and figure out where the normal positions of things are. And when they move, it's doing all kinds of amazing things to figure out whether they're mad at you. So, and in general, the scientists who study these kinds of things think it's pretty clear that what we've got in our heads is an assortment of really useful devices, okay, plugged together in some pretty useful ways that work in a variety of circumstances, but not all circumstances. And where did they come from? Well, they came from evolution. And that's not very controversial among people who actually study these things. And a lot of the time when people study this, what they look for, and either find or don't, is motivated by an evolutionary theory. That I think it would have been useful when we were evolving to be able to do this. I think it would have been dangerous if you did it that way. And what you generally find is that the brain does, in fact, look like an evolved computer. That it makes certain kinds of inferences in certain ways, largely because that's what would have been useful in the past, and the ones that did it in less effective ways, they died. Okay. And it doesn't look like a computer that anybody designed on purpose. Evolution tends to produce things that sort of look designed, and in that sense, the brain is brilliantly designed. The brain is just the most amazing thing we know of, by far. But it also, there's just like really dumb design mistakes that have been in there for millions or even hundreds of millions of years. So, for example, when you feel like you're suffocating because you've got a plastic bag over your head or something, or you're in too small a room for too long, why is that? Well, you'd think it would be because something would detect that you don't have enough oxygen, right? I'm running out of oxygen. That's the problem. I don't want to run out of oxygen. Well, no, there's this problem with that that's not how it works. That what we actually detect is the presence of carbon dioxide, which is not in itself very dangerous. And hundreds of millions of years ago, our nervous system evolved to guess whether there was enough oxygen by detecting whether there was too much carbon dioxide, which in most environments since then, that has worked pretty well because the fraction of oxygen in the air has remained pretty constant. And in general, you only find, you usually, if you have high levels of carbon dioxide, you probably also have low levels of oxygen, and you really ought to get out. So detecting no carbon dioxide, lots of carbon dioxide is a good enough, handy way of detecting a lack of oxygen. And then there's some exceptions. There's certain caves you can walk into where, because of geological outgassing of various kinds, there's not a lot of carbon dioxide, but there's also there's not very much oxygen. And so some of these odd geological gases, you walk into a cave full of that, you can just think you're fine, not feel strange, and then all of a sudden you feel kind of lightheaded and pass out. Similarly, if you walk into a computer room with a halon fire extinguisher, you don't know that you really ought not to be there because you can fill a room with a gas that has no oxygen in it and you can't smell it. Right. You don't know that it has no oxygen in it, and you'll bop along for a little while and then fall down and die. And so if God had designed this gadget, he probably would have figured out how to make an oxygen detector. It's not actually that hard to do. Yeah. And then we have lots of other things that are clearly artifacts of sort of early design mistakes that evolution made. Like you've talked about before, how the retina of the eye, the nerve cells are on the wrong side of the retina. That light has to pass through little capillaries and things to get to them, which is why when you shine a light in somebody's eye, you can see all those little blood vessels.
I think it said squid eyes are so much better designed than ours. They're much harder. The cells are in the right orientation.
Octopus eyes are very, very similar to human eyes because they evolved by a similar path. Yeah. But they got that part right really near the beginning. Yeah. Yeah. Okay, so one of the things you learn when you study cognitive psychology is that our brains are making a zillion inferences, and most of them are right. We have these specialized hunks of our brain, and these specialized hunks may be in one region, like there's optical centers here and speech centers here, and planning goes on largely here, and our balance system that integrates visual information and inner ear information is down here. And so you have a lot of geographical locality within the brain of this function is done over here. But you also have functions that are spread through the brain by sets of neurons that are connected closely. So even though they're not physically adjacent, they have a lot of connections to each other, and they can tightly cooperate to solve some little problem, and not so much with other things. And so those are two kinds of modules we have in the brain. The brain's made out of a bunch of parts. Another kind of module we have is that we have modular knowledge, and that turns out to be really important in understanding the psychology of religion. That one of the problems of intelligence, and this, I've studied artificial intelligence, I did that in graduate school, and one of the things you find out in a hurry is you don't want to remember everything you know. That one of the big problems of building something intelligent is to make it not remember all the wrong stuff and be distracted by true and useful inferences that don't apply to the current situation. That you can use up astronomical amounts of computation by remembering too much stuff. So what you really want is to remember the right stuff at the right time. Okay. And our brains tend to organize knowledge in related hunks. That whether they're stored near each other in the brain or not, they're cued by the same things that remind us of a set of issues. So that there are certain things we reason about in certain ways and remember related things that we can use to reason about them and say, oh, is this one like that or is this one like that? But our brains are very, very, very selective in what they remember and what can remind us of it, because if they weren't, we'd just be overwhelmed with memories all the time that would be useless. So one of the things about that is this doesn't look like a divinely designed gadget. It doesn't have infinite computational power. It has huge computational power, but it doesn't have infinite power, and it has to act like it. This is a gadget that's effectively designed by evolution to solve a problem, and it does it more or less well. So when we're functioning, there's usually a good reason why we're reminded of the things we are reminded of and why we're not reminded of most of the other things. There's a good reason why, for example, when interpreting things we see or something I hear somebody say, little parts of the brain make theories about what that means. Is that an edge or is that a shadow? Did he say that? Is he mad at me? That kind of thing. But we make a whole lot of errors, most of which we get away with. Some little part of the brain may come up with some little theory about some part of the visual field or some little thing you said, and some other part of the brain will go, no, I don't think that could be right. And you don't even notice most of this consciously, that you make lots and lots of mistakes, but they get filtered out before they get far enough in the process for you to be consciously aware of them. And that has a lot of implications for how you think about what life is like. What nobody knew until about 50 years ago is that life is very, very hard and very, very complicated. And our brains do an amazingly good job of getting lots and lots of stuff mostly right, or finessing it a little so that even if they're wrong, it doesn't matter. And that makes you think differently about what happens when people believe stuff that turns out not to be true. It turns out everybody believes lots of stuff that turns out not to be true, and there's this very risk-prone process of analyzing and filtering. And that your brain, the higher level functioning of your brain, is largely committee-like. You got different parts of your brain talking back and forth, and there's not really one that's in control that's you. Okay? And there's other parts of your brain that do serve subsidiary functions, but a lot of them are committees too, and they're arguing. And so, like any other organization of a large number of things that are doing something like thinking, mistakes will be made. Okay? And some of them will get caught and some of them won't. And the reasons why each module in the brain that does some particular computational task makes the kinds of mistakes it makes are often clearly, they make sense in light of evolution. So for example, suppose you're driving down the road and you're looking over here, and as you're looking back, you see in your peripheral vision this beige shape going across the road, okay, ahead of you. Well, you're likely to, look over there as soon as possible to get more information. Slam on the brakes if you're not too afraid of being rear-ended. Maybe swerve. And you're likely to think it's a dog or a cat. You're likely to see it as a dog or a cat, that your visual systems will jump to the conclusion that it's a dog or a cat. And then maybe you notice, no, it's an empty grocery bag blowing across the road. And you're surprised. You're going, I thought that was a dog. Well, there's evolutionary reasons for this kind of thing. And because when you're dealing with animals, and this was true of our hunter-gatherer forebears for millions of years before we developed the kind of culture where we have cars, animals are very interesting things to have in your environment. And there's certain basic categories of things that seem to be built into the brain for evolutionary reasons. And there's only about a half dozen of these major categories. And one of them is animals. So we have the category of plain old inanimate objects, things like rocks and mountains and clouds and stuff. We have the category of plants, which they behave differently. They do things like growing and reproducing, and maybe you can eat them, and that's one of the reasons why that's an interesting category. They probably won't eat you. Then we have animals. Now, animals, they're real interesting because they move around unpredictably. So if something might be an animal, you want to pay attention to it because it's not, it might be moving in a straight line, but that doesn't mean it's going to continue to move in a straight line like a rock. Okay. And it might turn around, it might run over and bite you, or you might be able to run over and catch it and eat it. So we seem to be wired to develop this category of animal and find it particularly interesting, partly because it's hard to think about and it's important to think about. Animals are more difficult to think about than rocks or clouds or rivers or whatever, because they have their own goals. They get around in the world, and you have to think about them psychologically. We're evolved to be able to think about other minds. And when it comes to non-human animals in general, we recognize that they can have goals like to get to you and bite you, or to get away. But it's not a real complicated kind of thing. Animals don't make promises. They don't rip you off. They might rip something off of you, but they don't rip you off. They don't have that concept, and you know it. And then we have humans. And humans, they can rip you off. You think very differently about humans. That in general, when a human does something, you bring to bear a lot of very special purpose knowledge and brain machinery for thinking about humans. We're evolved to be able to see other people as people and infer from all kinds of subtle cues, things about their mental state, what they're thinking, how they feel about us, and what that implies for our social relations. Like, can I trust this guy, right? We don't think that way about animals in general. Wait a minute, now I've lost my place again.
Something our brain was not designed to do.
Right. Okay, and there's actually a few other categories. One of them is tools, things that are not animate but aren't natural. And tools are interesting to us. They remind us of certain things and make us think about certain issues. Like if I'm a hunter-gatherer and I'm wandering through the woods and I see a rock, it's a rock, who cares? I might think about it as a physical object I could throw at an animal, or something I could build something out of, but it's just a rock. I think about it as just physics. So we have this intuitive idea of physics, that things have momentum. You can throw them harder, they'll hit things harder. Throw it up, it'll come down, stuff like that. But it doesn't have biology. So we have this ability to think about biological things differently from non-biological things. The ability to think about animals differently than other biological things, and especially the ability to think about humans very differently from other animals. When we do that, I need to go back to our evolutionary environment. Imagine you're a hunter-gatherer, and you don't have biology, you just have folklore. You know, a lot of people know that this plant can kill you, that plant's good to eat, stuff like that. So your average hunter-gatherer is a very smart person who knows about thousands of plants and where they bloom, you know, when they bear fruit, whether you have to cook it before you eat it or you'll die of poisoning, what might be good for a headache or something like that. So hunter-gatherers have huge amounts of knowledge, they just don't have modern science, which means, like most people who don't know a lot of science, they don't have a deep theory of why a lot of this is true. Okay, they have what's called a folk theory, that a lot of the time that's just, we don't know why this is good for what ails you, but it's good for what ails you, okay? Which, the same thing about psychology, that for millions of years we've been a bunch of computers made out of meat, walking around the world, and people haven't known that. They haven't known, like for example, the ancient Hebrews didn't know that thought happened in the brain. Aristotle didn't know that either. Yeah. The ancient Hebrews thought that thought happened in the heart and emotions happened in the kidneys. Okay?
Okay.
Well, despite that complete lack of scientific knowledge about thought and emotions, people did know a lot about emotions, that we're evolved to be able to know this stuff, and our cultures developed to embody it, that you know when you steal from somebody, they're likely to get pissed off. Yeah. You know, if they do you favors and you don't do them a favor, they're likely to resent it, things like that. And so this is something that we see evidence of from brain damage patients or people with abnormal brains for genetic reasons, that like autistic people don't seem to grasp that other people are people. Okay. They have difficulty imagining that there's another mind and imaginatively putting themselves in that position. So moving on a little bit to Religion Explained by Pascal Boyer. That's B-O-Y-E-R. This book is specifically about the evolution of religion, both the mental substrate for religion and the social phenomenon of religion. And there's been, for thousands of years, lots of different theories of religion. Why do we have religion? What is religion? And for hundreds of years, or over 100 years, we've had psychological theories of religion by allegedly scientific psychologists like Freud. Okay. And a lot of these theories, both ancient theories and some of the more modern theories don't really explain what they set out to explain. So you have a lot of theories that, well, people believe in certain kinds of religious things because it makes them feel better, okay? And a lot of people can accept that as satisfying. Oh yeah, people believe what they like to believe.
Yeah.
But that's really not much of a theory of religion, because people don't in general believe what they like to believe. Because if we did just believe what would make us happier, and it wasn't true, a lot of the time we'd get eaten.
Yeah.
Okay, so like, for example, when you're driving down the road and this thing is going across the road, do you believe it's harmless and drive right into it? Yeah. No, in general you don't. You guess that it's potentially harmful, or at least very interesting. And so you actually sort of, a lot of the time, you say, better safe than sorry, and assume the worst. And that's one of the common kinds of patterns in our reasoning, that when a module in our brain is figuring out something and making some guess, a lot of the time it doesn't distinguish, it doesn't even try really to distinguish between something that's really highly likely or something that, if it's true, you'd better watch out. Mm-hmm. So we have these various detectors for various things in the world. We have parts of our brain that specialize in detecting animals. They notice jointed legged motion and slithery things, and can tell that the difference between that and something water flowing or a tree branch waving. We also have other detectors in our brains for things like liars and weasels, okay, that we're highly developed to be able to guess whether somebody's lying. But in a lot of these cases, our unconscious thought processes actually give us pessimistic answers, where, like, if it's somebody you don't know pretty well and you have some ambiguous evidence that indicates they might be lying, you're much more likely to think they're lying than if it's somebody you do know. Okay. People who are different from you, you're likely not to trust. Better safe than sorry. Okay? And a lot of this stuff is evolutionarily useful, but not really rational. Okay. That it might be useful to realize that you don't know, I mean, it might be rational to realize that you don't know somebody very well and know that you don't have good grounds to trust them yet. But a lot of the time, things just slot into place, and you actually think they're probably dishonest and actually dislike them without very good evidence. Okay. So that's one of the kinds of mistakes we make in reasoning. One of the things about hunter-gatherers, like we were through most of our evolution as people per se, is that because they don't have deep theories of biology, then they have these rough theories of plants versus animals. Anything that doesn't fit neatly into those categories is very interesting. In general, people have to categorize the world. Yeah. They have to divide the world up into different kinds of things so that they can bring to bear different kinds of knowledge, learn different kinds of things. So people tend to be interested in things that violate categories. So, like, butterflies are very interesting because they grow, a lot of animals, they just grow by changing scale, essentially, or maybe changing proportions, if you look at a puppy developing into a dog. But butterflies look like a worm, which is really an insect in larval form, but who knows the diff, right? And then they look like maybe a plant. They just sit there and don't seem to be doing anything for a long time because they're a pupa. Yeah. And then they look like sort of a bird, okay? Well, whenever your categories break down that way, you know that there's something wrong with your concepts, or that there's something deep going on, okay? And there is something deep going on. It's called developmental biology, and a really interesting evolutionary thing that resulted in butterflies. So people are in a pre-scientific world, then you have these categories that are very important for organizing your knowledge, but you also have a fair number of exceptions to those categories. Of this kind of thing is a one of those, but it's also a one of those. So you have these very strong expectations of things that are true of, say, plants or animals or people. And you're open, because you've seen it, because you don't have a deep theory that you really know is right and has it all thrashed out, then you also are always open to the idea maybe there could be a freaky thing that was a one of these and a one of those. Yeah. Okay, so like, and this gets to some of the things about what can be or can't be in a religion. Okay. You can do tests cross-culturally and find out which which things people consider interesting or supernatural or whatever. So, for example, if you tell a sort of religious story about a table that was sad when people left the room, people can sort of recognize that as a kind of religious kind of thing, that, you know, it's kind of a mystical table, and it knows its function, and when the people go away, it can't do its function. But if you tell a story about, there was this table, and it was made out of chocolate that never melted, who cares, right? It's just not an interesting, deep violation of our categories. So one of the things that religious concepts tend to have in common is that they involve really deep category mistakes. That something is in this category, but it's also in this category. It's a statue, but it can listen to prayers. Okay? It's a statue, but it can bleed. It's a mountain, but it can eat. We can sacrifice to the mountain. You know, and so so part of what makes that kind of religious idea possible is this lack of a deep, certain theory about things, such that sort of anything's possible. What makes it survive as a religious idea is it's interesting as hell. Okay? That if you tell somebody, so they've done this experiment where you tell people, some people you tell the story about the table that was made out of chocolate that never melted. 4 months later, they don't remember it. Right? And they're not going to go, you know, out of this list of 50 things you have them read about, this is not one they're going to go home and talk to other people about. But, you know, that statue that eats, that statue of a virgin that bleeds, or that mountain that eats people, that's like, oh yeah, there was this interesting story. And so, you know, Boyer's theory is partly about particular aspects of the psychology of religion, like why we can entertain certain ideas and not others, and it's partly about the sociology of religion, why certain ideas spread, and what it takes to kill them. So one of the things that I was talking about earlier about people's theories of religion often involve wish fulfillment, and either wish fulfillment, yeah, I believe I'll live forever because that would be really cool, or anxiety reduction, that we believe things that console us, like about the afterlife is one of the examples. But if you actually study the psychology of rituals, one of the things that's going on with a ritual, in terms of just basic cognition and how planning works and how social perceptions work, how we perceive how other people are behaving, there's something funny about rituals, that they're very stereotyped, scripted activities. And one of the things about very stereotyped scripted activities is, when do you follow instructions very carefully to the letter for reasons that you don't know? And in general, people don't know. There's a lot of things about rituals that we don't know why we use this sword to tap the guy on the head, or somebody might have had a theory at some point, but it got lost. So most things about rituals are passed down sort of unanalyzed, without a theory behind them of what it really means. And clearly, the theories that people do have are sort of shallow and not really nearly as important as the ritual itself. And people think it's important to follow the steps in the exact order, do the motions in the prescribed way, only do it in this kind of location, not that kind of location, because if you do it wrong, things could go really badly. Okay, well, that is a sort of a vicious, infectious kind of meme. A meme is an idea that gets reproduced and has a lot of power to get itself reproduced. And one of the reasons why is that when you see people acting ritualistically, following a set of instructions very, very carefully, very rigidly, without knowing why, if it's anything but religious, that tells you something. One is that they're doing something important. They're going to a lot of trouble to do it, and they're doing it very carefully. And the other is they're doing something dangerous. Okay? Because if you screw up, all hell could break loose. And so one of the ways this suckers people into this feeling about rituals that they're important and they get at something deep, because you're acting like it's important and dangerous, right? And so that's, on an unconscious level, one of the reasons why ritualized stuff makes things seem more important, and that helps the idea of the ritual propagate.
So could that ritual have originally been things like cooking? You have to treat this fruit or vegetable
Right.
or animal in a very special way
Right.
in order to make it safe to eat.
Right, and there's several things going on there. Like if you look at dietary restrictions in different cultures, some of those dietary restrictions may have had good reason at some point. Somebody got sick from eating shellfish, so says in Leviticus, don't eat shellfish, okay? But a lot of it is just a list of injunctions.
Okay.
And that serves several different functions. Some things like that are things that there was some good reason for culturally at some point, or at least given what they knew then, there might be. We know better in general. Other things are sort of a codification of standard practice. This is what we do. And you codify those things when you have conflict with somebody else. Mm-hmm. So when you have a culture that is in conflict with another culture, and you get xenophobia, fear of strangers.
Yeah.
Okay? And people start emphasizing the things that make them different. Yeah. This is how you can tell they're not us. Yeah. They don't do this way. Yeah. And so things that were not previously important get more and more importance because they're used as signifiers of something else. Okay. You know, who cares about circumcision? But, you know, if you're an Orthodox Jew, you got to be circumcised. Otherwise, you're not a Jew. Yeah. You know, so so there's various ways that we observe people's behavior and infer things about their goals and their reasons for doing things. And a lot of ritualized things play into that and sucker us into thinking it's important. When you understand what supernatural concepts are, that what they really are these alleged things that mix these different categories. Yeah. Like, so people with the folk theories of biology and psychology and stuff, without a real scientific understanding of it, are fascinated by freaky things, like a body with a mind in it, and other bodies that don't seem to have minds in it, or not our kinds of minds. There's animals, there's humans. And death is interesting. Probably, it's fascinating in a certain way because, like for animals, hunter-gatherers often see dead animals. They'll find them out in the woods. They'll kill them. They'll hunt them and kill them. They'll do things like that. So they're used to seeing dead animals. But a person is something else than an animal. And so it's shocking when you have this kind of being that you normally bring to bear a lot of cognitive processing to think about their goals and plans. It's shocking when they suddenly don't have goals and plans anymore. Now they're like a dead animal. They're just meat. Yeah. Okay, that's very shocking. And Boyer talks about how that seems to be a big part of grieving and part of the reason why people find the afterlife plausible. It's because parts of your brain get entrenched in the idea of a person as a person. After somebody's died, you don't immediately revise all your unconscious beliefs that assume that they're alive. And so, you know, somebody close to you has died and you see something of the kind they used to like and you go, oh, he'll like that. Yep. And you go, oh, I guess he won't, he's meat. Okay, so one of the things that in a folk belief system before the scientific knowledge of these things is it's really not clear what relation minds and emotions have to bodies. Yeah. Right? So it's perfectly plausible that whatever a mind is, well, it's just stuck in a body for now. Maybe it doesn't die when the body dies. Yeah. You know, we know lots of bodies die. We see it happen to animals and occasionally to people, but we don't really know what minds are, so we have no idea whether they could be immortal or something. Okay. Be reincarnated in an animal or whatever. But when we do have a scientific understanding of the mind, and I think we basically do now, we actually know what not only thought but emotions are. And it all happens in the brain. Everything you think, everything you feel, everything you remember, it all happens in the brain. And the mind is essentially an extremely complicated computer program running in an extremely complicated computer. And when you realize that, you realize what happens to the program when the computer falls apart. Yeah. You have a program running in a computer and you smash that computer to bits and, you know, burn it up or something, which is essentially what happens to our bodies at a micro scale. Yeah. Lots of machinery falls apart and stops being machinery and ends up just being goo. The process of that machinery doing what it does comes to an end. And so minds, when the body dies, the mind dies with it. Yeah. And immortality would be very difficult to achieve because the only way the mind could survive would be to be transferred into an almost identical computer. A computer very, very similar to the human mind, which is a very complicated and very idiosyncratic computer. And the chances are that there is no way that can happen because there's no such other computer. There's not extra human brains lying around or things that can simulate them and compute the same things and
but that's
different materials.
That's the situation today. Who's to know that?
Right.
In 100 years, we could have something.
At some point, it may be possible to gradually replace bits of our brains with computationally equivalent pieces of other matter and continue to live long after our bodies could die.
Yeah.
But immortality of the kind that people have talked about for a long time, that appears to be impossible, because once you understand that the mind is computation, you got to have the computer.